You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Security appliances are critical components in cloud environments designed to detect, prevent, and contain malicious activity. These tools, such as Web Application Firewalls, Intrusion Prevention Systems, Intrusion Detection Systems, and Network Access Control form part of a layered security strategy. However, like any system, they can malfunction or be misconfigured. A faulty appliance may block legitimate traffic, misclassify endpoints, or even fail to detect real threats. In this episode, we explore how to troubleshoot security appliances effectively in the context of cloud deployments. The Cloud Plus exam frequently includes topics related to these appliances. Candidates must be able to interpret WAF alerts, IPS IDS detection behavior, NAC enforcement outcomes, and general policy enforcement failures. They must also understand how these systems integrate with cloud-native constructs like virtual private cloud configurations, security groups, and elastic scaling. Understanding appliance behavior, reading logs correctly, and identifying configuration gaps are all vital to maintaining secure and stable operations. One of the most immediate symptoms of appliance-related issues is unexplained connectivity failure. A security appliance with overly strict rules or a failing inspection engine may silently drop traffic. Users may experience timeouts, failed login attempts, or entire services becoming unreachable. Logs from the appliance will typically show dropped packets, denied connections, or rejected sessions. Cross-checking logs against user reports helps pinpoint the affected system and confirm the appliance's role in the disruption. Web Application Firewalls filter HTTP and HTTPS traffic, scanning for injection attempts, cross-site scripting, and other application layer attacks. A misconfigured WAF may block legitimate API requests, user form submissions, or dynamic page content. Candidates must know how to examine WAF rules, identify false positives, and adjust filters. Most platforms allow whitelisting specific inputs or relaxing certain rules to allow necessary traffic, while preserving protection against true threats. Intrusion Prevention and Intrusion Detection Systems inspect network traffic for signs of known attacks. An IPS actively blocks malicious traffic in real time, while an IDS logs suspicious activity for later analysis. These systems rely on signature databases and heuristics to function properly. False positives may arise when rules are too broad, while false negatives occur when the signature set is outdated or improperly tuned. Troubleshooting involves reviewing what traffic triggered alerts and whether those alerts are accurate reflections of threats. Alert logs are the primary data source for appliance behavior. These logs include event time, source and destination IPs, match signature IDs, and the policy actions taken. An effective troubleshooting process requires correlating these alerts with operational events, such as a failed file upload or login, to determine if the appliance is the source of the issue. Alerts should also be validated against known attack patterns, or with help from secondary tools like endpoint protection or SIEM platforms. Network Access Control Systems regulate which devices are allowed to join the network and what privileges they receive. If a NAC system misclassifies a device as untrusted or fails to verify endpoint posture, it may prevent network access entirely. Troubleshooting involves confirming that agents are installed and updated, policy groups are correctly assigned, and connection status reflects the actual health of the endpoint. NAC-related failures often appear as unexplained device disconnects or access denials. Monitoring dashboards provide a holistic view of appliance health, traffic inspection volume, rule match frequency, and resource utilization. Overloaded appliances may drop packets, throttle traffic, or fail to apply rules. Monitoring memory usage, CPU load, and event queues can reveal whether the appliance is overwhelmed. Any spikes in traffic, particularly during scaling events or attacks, should be analyzed in relation to appliance thresholds and alert activity. The physical and logical placement of the appliance within the network architecture also plays a role in troubleshooting. If a security appliance is expected to inspect traffic but is misconfigured to sit out of band or is bypassed by routing rules, its protection may be ineffective. Routing issues, incorrect NAT configurations, or improper interface bindings can all lead to the appliance being skipped entirely. Teams must verify that the intended traffic path passes through the appliance and that inspection is occurring as expected. Configuration drift or rule corruption is another common cause of malfunction. Changes made manually or via automation may not align with security baselines. Backup configurations should be compared against current settings, and rule integrity checks should be run. If drift is detected, teams should either restore from a known good configuration or reapply the approved rule set to ensure enforcement is consistent with policy. Security appliances must integrate properly with cloud-native networking constructs. For example, a WAF in a hybrid environment must work seamlessly with security groups and NACLs. IPS/IDS systems must be compatible with cloud VPC routing, and NAC tools must communicate with cloud identity providers. Mismatched expectations between the appliance and the cloud environment can render protection incomplete or ineffective. Documentation should always be consulted to confirm support for cloud-specific features, limitations, and integration steps. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Testing appliance rule enforcement is a critical step to validate that protections are functioning correctly. Simulated attacks using tools like curl, burp suite, or custom test scripts can mimic common threats such as SQL injection, cross-site scripting, or path traversal attempts. These test inputs help confirm that the Web Application Firewall, or IPS, reacts as expected. However, care must be taken to ensure these simulated payloads are flagged appropriately and do not pollute production logs or trigger unnecessary escalation within security monitoring tools. Logging consistency is key to maintaining visibility and supporting audits. When logs are delayed, incomplete, or missing, teams may lose critical context about security events. These issues can stem from storage quotas, log agent failures, or improperly configured forwarding rules. Troubleshooting should include verification of log retention settings, pipeline health, and ingestion confirmation in centralized platforms. Logging should be adjusted to balance verbosity with performance, ensuring that essential events are captured without overwhelming analysis systems. Firmware and signature updates are foundational to maintaining effective protection. A security appliance running outdated firmware or relying on old threat signatures is inherently limited in detecting modern attacks. Update procedures should be automated or regularly scheduled and include signature updates from trusted vendors. Cloud Plus scenarios often include reminders to validate whether appliances are properly updated, especially after deployment or following periods of maintenance neglect. Rule granularity affects both the accuracy and usefulness of appliance behavior. Broad rules tend to produce large numbers of false positives, while overly narrow rules may miss emerging attack patterns. Teams must assess which rules are generating the most alerts and whether they are contributing to meaningful detections. Tuning signature sets and introducing context-aware rules, such as those that consider HTTP method, user agent, or URI structure, can improve signal-to-noise ratio and operational response speed. Coordination with third-party vendors or managed service providers may be necessary when troubleshooting managed security appliances. When issues arise, teams should prepare logs, timestamps, example traffic data, and the observed symptoms before escalation. Support interactions are improved by having this data organized and documented. Maintaining up-to-date SLAs and understanding the escalation paths ensures that external support is timely and effective when internal resolution reaches its limit. Traffic shaping and rate threshold controls are especially relevant for intrusion prevention and WAF systems. High-volume traffic, whether legitimate or malicious, can trip rate-based detection mechanisms. Tuning thresholds to match the application's expected load is essential to prevent disruptions during peak usage. Troubleshooting rate-based errors involves examining alert logs, adjusting protection thresholds, and verifying that safeguards like burst buffers or retry limits are configured appropriately. Any change to appliance policy should be followed by thorough regression testing of the affected application. Rule modifications may inadvertently block legitimate features such as login portals, webhooks, or API integrations. Regression testing ensures that normal workflows remain functional. These tests should be documented and include clear pass/fail criteria so that unintended consequences of policy changes are caught early and do not cascade into support escalations. As with any troubleshooting effort, documenting the resolution process is not optional. Each rule adjustment, exception granted, or custom signature created must be recorded, with the reasoning behind it and any test results that confirm the fix. These records support repeatability, reduce tribal knowledge dependence, and provide a trail for future audits. Whether stored in configuration management tools or a centralized operations wiki, this documentation is essential for team alignment and security governance. Troubleshooting security appliances in cloud environments demands a blend of technical depth and architectural awareness. Teams must understand not just the behavior of the appliance itself, but also how it interacts with cloud-native infrastructure, application workflows, and user behavior. A well-maintained appliance provides a valuable layer of defense, but only when properly tuned, monitored, and tested. Candidates for the Cloud Plus certification must be comfortable interpreting alerts, simulating test traffic, tuning rule sets, and maintaining policy documentation as part of an overall security operations strategy. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.